Multiplicity. The term multiplicity refers to how many instances each zero appears in a polynomial. The multiplicity is simply the power of the factor from which the zero or the root comes from. If you watch the video on finding zeros, I mentioned those powers. We would come back and talk about those powers. All right. So even multiplicity means that the graph of a function bounces off of the x-axis or touches the x-axis and turns around at that particular zero or root or x-intercept. If you have an odd multiplicity, that means that the graph of the function crosses the x-axis at that particular zero or root. So if it's above the x-axis and it gets to an odd multiplicity zero, it crosses over and goes negative. If it's negative, it crosses over and goes positive. So here's some examples. Okay? So here on this graph, notice here's an x-intercept and here's an x-intercept. This one comes down here and touches or bounces off the axis and goes back up. That's an even multiplicity. Over here, this one is above it, crosses over to below it. That is an odd multiplicity. Okay? So here, odd, cross. Cross, that's odd. Bounce or touch, that one's even. Okay? Bounces, touches is even. Okay? All right, so let's look at another example. Right here. This graph comes down here that crosses the axis here. That's odd multiplicity. Bounces off of it here and goes back. That's even. And this one is odd again, right? So you have three x-intercepts or three roots or zeros there. And the two on the outside, this one is odd and this one's odd because they cross the axis. And this one touches or bounces off of it. So it is even multiplicity. We don't know what the multiplicity is, but we know it's even and we know it's odd, vice versa. And let's look at one more example of these. This one here comes down and crosses over, so that's odd multiplicity. Oops, sorry. And then this one here bounces or touches, and so does this one. So both of those are even multiplicity, All right, so those are some examples of graphs. If you were graphing these things, we're not going to graph them right now. I'm just saying if we were graphing them, then that's something that would help you as far as graphing goes. You would know at that particular zero, does it bounce off the axis and go back the way it came from, or does it cross over the axis from positive to negative or vice versa? Okay? So here, we found these zeros earlier in the Finding Zeros video. So we're not going to go back and find them again. We already have them. Let's talk about the multiplicity. It is simply the power of each zero. So where did 9 come from? It came from this one right here. What is the power of that parenthesis right here? It's understood to be what? A 1. So the multiplicity is 1. And then what about the negative 7? It came from this one. And what is that power there? 2. So then the multiplicity is 2. And then NA again, this is all NA here. If you haven't, if you don't have a 0, then it does not matter, right? Again, I'm going to put the same number of blanks no matter what. Okay, so my test would not just be find the zeros. It would look like this with all these things across here and maybe even some more stuff. Okay, so, but again, I'm just not giving away how many there are. So that last row is not applicable here. It doesn't matter. So all of them are NA. They don't matter. Draw a line to it, whatever you want to do. Okay, they don't count. All right. So the multiplicity of 1, this is an odd number. So what does it do? Well, if we look back, odd multiplicity crosses, right? So odd multiplicity crosses, that's what we're going to use a C for, cross, and then 2 is an even number, even touches or bounces, so we're going to use T for that. So I'm going to use C or T, C for cross, T for touch. Touch is also the same thing as bounce. So then on the next one, we look down here and we have 0. This 0 came from here. What is the power of x? 1. So the power is 1. That's an odd number. So what does it do? It crosses. What about negative 1? It came from right here. What is the power? 1. So that also is 1. So that is odd but crosses. Where does 4 come from? This one. What is the power? 5. So the multiplicity here is 5, which is what kind of number? That is also odd. So it crosses. Odd multiplicity crosses the axis. Even multiplicity touches or bounces off. Where did 3 halves come from? Which one? This one, right? What is the multiplicity that goes with that? The 3 right there, right? So the multiplicity is 3, which is odd. Odd multiplicity crosses, right? And then what about negative 8? What comes from negative 8? It comes from, or where does it come from? The x plus 8. And that power or that multiplicity is 7, which is odd. Right? It doesn't matter what these numbers over here is. 3/2 is not even nor odd. It's neither one. It's a fraction. So it's not whether the 0 is even or odd. It's all about this number here. That's odd, so a C. That's odd, so a C. Doesn't matter. This could be Mickey Mouse or Minnie Mouse. Doesn't matter. And then negative 2. Negative 2 has a multiplicity of what? 4. And that's even, so it touches, right? It touches. And then these two, if you recall, we had to actually factor them. But here are the zeros. We found them earlier. Again, on this one, this final row is NA. We don't care about it. It's not applicable, right? So just forget that row is there. 0, though, if we look back at the factored form, it was this right here. Okay? So the multiplicity of this one was 1, and this one was 2, and that 1 is an odd number, so it crosses. 2 is an even number, so it touches. And then this one here, if we go back, the factored form, if you were to factor it, if you go back to that video, it was factored into this, and I should have had that here, I suppose. It factors into x plus 5, x plus 3, x minus 3. Each one of these powers is what? 1. They're all 1. If all of them are 1, they're all odd, and all odds do what? Cross, so they're all C's. Okay, they're all C's there. So that is multiplicity. That is multiplicity.